In section 10.3 we discuss how water can sometimes function as an acid and other times as a base. So we've seen examples when water was combined with an acid where water functioned as a base. That is, it functioned as a proton acceptor. So if we take the acid HNO2, add it to water, a proton will be transferred from the HNO2 to the water, forming the hydronium ion and the nitrite anion. Conversely, if we add a base to water, we will see that water will function as an acid. That is, a proton will be transferred from the water to our base. In this case, our base is ammonia, and this results in the generation of the ammonium cation and the hydroxide anion. So compounds that are like water that can function both as a base and an acid are described as being amphiprotic, kind of like how an amphibian can live on both land and in the water. Water, or any other amphiprotic species, has a dual nature. So in this example from the book, we're asked to identify whether water is functioning as a Bronsted-Lowry acid, that is a proton donor, or as a Bronsted-Lowry base, that is a proton acceptor. And I think in the first case, it's pretty easy to see that the water is donating a proton to the nitrite anion. We can see that because the nitrite ion literally gains a proton. So this is what's going to happen, just like that. Oh, not OH minus, that's the wrong thing, is it? H plus. So clearly, in this case, the water is functioning as the donor, or acid. This one looks a little scary, but it's really not that bad. Let's have a look at what's happening to the water here. It looks like it's gaining an H+, and if we look at what's happening to the other thing, looks like it's losing an H+. So pretty clearly what we can see is happening is that our first species there, it's called acetic acid, it's the acidic component in vinegar, is donating a proton to the water to form the hydronium ion, and then that leaves an anion that remains. That anion is actually called the acetate anion. So you can see what's happening here is a proton is going that way. So water is functioning as a proton acceptor or a Bronsted-Lowry base. So in the first case it's an acid, and in the second case water is a base. Okay, and that concludes our section on water as both an acid and a base.